So this week we are doing more radicals practice. The first part of this you've already done. We did it before Christmas break. Okay? So a radical is just a square root. The number inside the radical we call, does anyone remember what that was called? That was a long time ago and we probably haven't used this vocabulary word a ton. No, it's okay, just say no. It's a radicand. When we are simplifying our radicals, it's super important that we know what our perfect squares are. How do you find your list of perfect squares? You just square all your numbers. So what's 1 squared? 1. What's 2 squared? Do you have a pencil, Gavin? Do you have a pencil? Maybe go get one. What's 2 squared, guys? What's 2 squared, Cammie? Y'all have calculators. What's 2 squared? Tell me answers, guys. Come on. 4. What's 3 squared? 9. 4 squared? 16. 5 squared? 25. 6 squared? 36. 7 squared? 49. 8. 9.
81.
10. 11. 12. Again, we have calculators if you need help. 144, very good. 13 squared. 14 squared. And 15 squared. 225. So when we are simplifying our radicals, we are going to look and see if the radicand, the number under the radical sign, is divisible by any of these perfect squares. If your radicand is divisible by a perfect square, you are not fully simplified. Okay? We good? Do we kind of remember this? Remember this, the calculator is going to help us a lot. Okay, we have our 3 rules. You can have no perfect squares except for 1 inside the radical. That's what I was just saying. If the number under the radical sign is divisible by a perfect square, you are not simplified. Okay? The second one is you can have no fractions inside the radical. Okay? No fractions under your radical sign and no radicals in the denominator of the fraction, in the bottom of a fraction. Okay? So, we are starting just by simplifying. Okay, what I would do is I'm always going to start by going to the calculator. So let's all have our calculators. And potentially this is going to be a perfect square. So I'm always going to just type it directly in the calculator. Oh no, it's not a perfect square. Okay, so I can't just do this on the calculator. Okay. Can anybody tell me what's a perfect square that 12 is divisible by? 4. Okay, and if you don't know, remember you can go to y equals. Let's do this with me. 12 might be kind of easy to see what the perfect square 12 is divisible by, but as our numbers get larger and larger, it might be more difficult. So let's all go to our calculator, go to y equals, and we're going to type the number under the radical divided by x. Go to the table, and I'm looking for my perfect squares, which I'm going to write them on the board really quick to help us. And when I write out my perfect squares, I don't even include 1 because everything's divisible by 1, correct? Correct?
Yeah.
And I'm just going to 144. So I'm looking for one of these numbers that's on my table, and I want the largest perfect square. So 1 and 12. 1 is a perfect square, but we don't look at that one. 12 is 12 on my perfect square list. Nope. 2 and 6 are 2 or 6 on my perfect square list.
6.
But we have to find a number on the table that's on my list. 3 and 4, are either of those on my list? Yeah, 4 is. Okay, well what is 4 paired with? 3. 3 is what kind of number? Prime. So therefore, I know that 4 is the biggest perfect square that 12 is divisible by. So I'm going to break this up as the square root of 4 times the square root of 3. Always put your perfect square before the non-perfect square number. Okay? It's just going to help you write your answer correctly. Are we okay with how I split it up? What is 4 times 3? 12. That's what I started with, right? Okay, now we need to go one more step. What is the square root of 4? 2. When you take the square root of the number and you get a whole number, does it still need to be under the radical sign? Like if I were to type this into my calculator, the square root of 4, is there a radical sign around that 2? No, so that's why my 2 doesn't have a radical around it. Okay? And then, can I take the square root of 3? Yeah. Is 3 divisible by perfect square? Is 3 divisible by any number on my perfect square list? No. No. So keep it square root of 3. Now, I cannot stress this enough. Always check yourself. Square root of 12, and then 2 square root of 3. So we are all typing it in the calculator, guys. I promise you, I know how to simplify radicals properly. Okay? So, the great thing about radicals is you can always figure out if your answer is equivalent to what you started with, which it always should be. If these two decimals don't match, you 100% got it wrong. If they do match, you still could get it wrong if you didn't take out the biggest perfect square, but at least your answer is equivalent to what you started with. Okay? So again, this whole unit, which is only 2 days, you are using your calculator to check yourself. Type it in the calculator first to see if it's an easy problem, and if it's not, then work it out, type your answer in, type your original in, and make sure the decimals match. Good? Do we kind of remember now simplifying our radicals from like 4 months ago? Yeah? Okay, square root of 18. What should I do first? What should I do first, Izzy? Type it in the calculator. Thank you. Square root of 18. Luke, what are we doing first? Type it in the calculator, guys. Guys, we have 2 more days of lessons, and then we're done for the year. So actively participate. It will make life a lot better.
Wait, really? This is the last day of notes?
2 more days.
After this, but this is the last piece of notes we're doing?
Yep. So, I got a decimal. Is that my correct answer then? Nope. So, I'm going to go to y equals, and I'm going to do 18 divided by x. So, I'm going to y equals now, and I'm doing 18 divided by x. Take your headphones out. Go quickly, sign out. Go to the table, and what am I looking for? What am I looking for on the table, guys? Numbers that are on my perfect square list. Is 18 on my list? No. Is 2 or 9 on my list?
Yes.
Yeah, 9 is, right? So how am I going to break 18 up? Perfect. Square root of 9, square root of 2. 9 times 2 is 18. Well, what is the square root of 9? 3. Is 2 divisible by a perfect square? Nope, 2 is prime, so 3 square root 2. What should I do next? Check on your calculator, very good. Square root of 18, I already typed that in, so now I'm going to do 3 square root 2. Do those decimals match? Again, my decimals match, so we have equivalent values. And my number under the radical sign is not divisible by a perfect square other than 1, so we are all good. Do we think we can do number 3 on our own? I want y'all all to do number 3 on your own. So whenever you type this in the calculator, you get a decimal. And then whenever you do 27 divided by x, 27 is divisible by 9. That's a perfect square. And 9 times 3 is 27. Remember, the best way to do this is to always put the perfect square before the non-perfect square. So the square root of 3, bless you. Sorry, the square root of 9 is 3. So it's 3 square root 3. When you type them in, your answer match. Okay, number 4. Remember, we always start with typing it in the calculator. What do we notice about this one, guys?
It's a perfect square.
We got a whole number, so do I have to do any work? No, there's my answer, done. Do we like those? I like the perfect squares, it makes life a lot easier. Okay, square root of 10. Oh no, we get a decimal, which means we're going to have to type this into y equals and do your 10 divided by x. Go to the table. 1 and 10. Is 10 on my list of perfect squares? 2 and 5, or 2 or 5 on my list right here are perfect squares? No. And notice I'm skipping these because these are decimals. We're looking for only pairs that are non-decimals. 5 and 2. Didn't I already have 5 and 2 on my list?
No.
So is 10 divisible by any perfect squares?
No.
No. You can't simplify it. There's your answer. Okay? Yes, ma'am. Good? Okay, now some of them are going to already have coefficients out in front. Type it in the calculator exactly as you see it. So I'm going to do 3 square root 28. Type the whole thing in exactly as I see it. And when I hit enter, I get a decimal, which means we're going to have to go to y equals. What am I going to type in y equals?
28.
28 divided by x. Do I care about that 3 right now? No, the 3 is already not under the radical sign. Okay, so I'm just trying to simplify what's under the radical sign. So the 28 divided by x. Go to your table. 28 is not on my list. 2 and 14 are either of those on my list? Skip because I have a decimal. 4 and 7 are either of those on my list? Yeah, 4 is. And what is 4 paired with? 7. And 7 is a prime number, so I know that 4 is the largest perfect square. So what I'm going to do, keep your 3 out in front. And how am I going to split up the square root of 28? Very good. Square root of 4, square root of 7. Drop your 3 down. Bless you. What is the square root of 4? 2. And I'm going to multiply it by the 3 because when you have a number glued to the radical sign, that means multiplication. Drop down your square root of 7 because 7's prime. And then what do these numbers become? 6. So 6 square root 7. So this one was a little bit more involved. We definitely are now going to go to our calculator and type in 6 square root 7. And we get 15.8. Do they match? Yep, so we got it right. Next one. 6 square root, I typed in way too much. 6 square root, I did it again, 48. And we get a decimal. Huh?
I didn't get all of 6.
There you go. So go to y equals and do 48 divided by x. And go to your table. Notice I'm going to drop down my 6 that's already outside the radical. And now I'm going to look on my list for perfect squares. Is 48 on my list? Is 48 on my list, guys? No. 2 or 24? No. 3 or 16? Yes, 16 is on my list. So I'm going to separate this into the square root of 16. 16 times what? 3. Notice how, again, I put my perfect square before my non-perfect square. So 6. What is the square root of 16, guys? 4. Square root 3. What's 6 times 4? 24. Square root 3. What should I do next? Check it. Let's go to our calculator. 24 square root 3. And do my decimals match? They do. We got it right. Okay, we're going to do one more together, then y'all are going to do one on your own. And we are not doing this whole notes thing today, guys, so don't stress out, okay? We're not doing all of this today. So for number 8, again, go directly to the calculator. All radical problems start at the calculator. Sometimes we make this way more complicated than we need to because you try to start simplifying it whenever it's just a whole number, okay? But this one is not a whole number, okay? So I'm going to go to y equals and do 200 divided by x. Is 200 on my perfect square list? 2 or 100?
Yeah.
Yes, 100 is on my perfect square list. And what is 100 paired with? 2, and 2 is a prime number, so I know that that's going to be the biggest perfect square. So I drop my 2 down. Out of 2 and 100, which one should I put first? 100, because 100 is your perfect square. Good job. And then 2. Again, drop the 2 down. What's the square root of 100? 10. Square root 2. Well, what's 2 times 10? 20. Notice how on all of the last 3 of these, I multiplied my original coefficient by the coefficient that I got to take out of the radical. The whole number I was able to take out of the radical. Okay? Notice on these last 3, I already had a coefficient out in front. And I ended up multiplying that coefficient by the number that got to come out of the radical to get my new coefficient. Because remember, a number glued to the radical sign, that means that you are multiplying your whole number by the radical. Okay? So whenever a number comes out of the radical, you are going to multiply the whole number by the number that came out of the radical. Okay? Okay, I want you all to try number 9 on your own, please. Try number 9 on your own. Okay, I saw lots of good stuff. So when you type it in, you get a decimal. Okay? Then whenever you type 32 divided by x into your table, your perfect square 32 is divisible by is what? 16. 16 times what gives you 32? 2. Okay? Drop down your negative 3. What is the square root of 16? 4. Square root 2. And then what's negative 3 times 4? Negative 12 square root 2. How are we feeling? Good? Okay, the next row is going to be slightly different. Go to your calculator. Again, first step is to always type it in your calculator. Trick here, guys. Gavin, sit up. You have to type it in exactly as you see it. Good morning, Ava. Get a notes packet. They're kind of weird today. It's a foldable, okay? And get a calculator, and then you can sit behind Evie, okay? Over in between Evie and Austin. So, the square root of negative 100. So we're all typing this in the calculator with me. I should see fingers on the calculator. The square root of negative 100. Notice how that's not negative square root of 100. Okay, that's a completely different problem. Type it in exactly as you see it. And it says non-real answers. If you remember back, can we take the square root of a negative number? Nope. In our world that we're in Algebra 1, there's no number that you can multiply it by itself and get a negative. Now when you go to Algebra 2, you go to a brand new world, and then you will be able to multiply and get a negative. But in Algebra 1, this is just going to be no real solution. And again, the reason I have to use the word real is because in Algebra 2, there will be imaginary solutions. Okay? Again, do you see how going directly to the calculator first saved us a whole lot of time of simplifying this whenever it doesn't simplify? Okay? We good? Okay, what do we notice about the next three, guys? They're all fractions. They still have radicals around them, correct?
But the rule says that you can't have fractions.
Correct. So, we still need to simplify them, but what do we always do first when we're simplifying radicals? We go to our calculator. Type it in the calculator exactly as you see it. Second square root. Type it in as a fraction. So do your alpha x to type it in as a fraction. 49 over 36. Please type it in as a fraction, not a division sign, because then it's going to give you a fraction answer instead of a decimal answer. And we know when we're doing radicals, you're not allowed to have any decimal answers.
Wait, I got fraction answer.
You're allowed a fraction answer, just not a decimal answer.
Oh, okay.
What did we get? Is there a decimal in my answer? Is there a radical around any of those numbers? No, so there's my answer. 7 over 6. Done. Again, if it doesn't give you a decimal, you're good. Also, what I love about the calculator is it simplifies your fraction if you put it in as the alpha x. If you put it in as a fraction, it simplifies the fraction for you. Now let's talk about why this worked though. What's the square root of 49? So the square root of the numerator gave you the numerator. What's the square root of 36?
6.
The square root of the denominator gave you the denominator. Good? Do we like those? Did we like that we didn't have to actually do any work? The calculator just gave us the right answer. Is that good? Okay, next one. Square root 5 over 81. Again, guys, your quiz over this is Friday, so I strongly suggest that we practice this. It's going to be your last real grade of the term, not the semester, but the term. A lot of us need a good grade on this quiz. When I type it in, I get a decimal. Are we allowed to have decimals? No. So what we're going to do is we're going to separate our fraction and simplify. So I can rewrite this as the square root of 5 over the square root of 81. Okay? When you have a square root of a fraction, you can write it. You can write it as the square root of the numerator divided by the square root of the denominator. 5 is what kind of number, guys? Prime. So can you simplify the square root of 5? Stays square root of 5. And then square root of 81. And what do I get? 9. So this becomes 9. Notice how there's not a radical around the 9 anymore because I typed in the square root of 81 in my calculator and I got a whole number. Also, 81 is on my perfect square list, meaning when you square root it, you get a whole number. Okay? What should I do now? What should we do now, guys? Check. Every single one of these we're going to check. So do your alpha x, square root of 5 over 9. Did that match my original Did we type it in, Ava? 2 more days of lessons, guys, then a quiz. I have faith that we can do it. We were very nice and gave y'all a lot of brain break last week. This week we need to get the brain going again, okay? Again, I cannot stress enough, put your original answer or your original problem in, put your answer in, make sure the decimals match. If they don't, you are definitely wrong, okay? We good? Okay, last one. Add the square root of a fraction. Type it in the calculator. We always start with the calculator. Always start with the calculator. Gavin, you have your calculator out and you're typing this in with me? The square root of a fraction. 18 over 25. Oh no, we get what? A decimal, okay? So, we're going to separate it. Square root of 18 over the square root of 25. There you go, Zach. Is 18 on my perfect square list, guys? No, but is 18 prime?
No.
No even number is prime other than 2.
Yeah.
So it's not prime. So we need to go to y equals on our calculator, and we're going to do 18 divided by x. So we're all doing this with me. You have to master simplifying before we can do any of our operations with them, guys. Go to your table. Is 18 on my list? No. 2 or 9, are either of those on my perfect square list?
Yes.
Yes, 9 is. So I'm going to separate this into the square root of 9 and the square root of 2 over, so that's my numerator. That's what the square root of 18 becomes, square root of 9 over 2. Sorry, the square root of 9 times the square root of 2. Is 25 on my perfect square list?
Yes.
Yes. What's the square root of 25?
5.
5. I don't have to have a square root sign around it. Good? We are not done though. What's the square root of 9? 3. So this becomes 3 square root 2 over 5. Now, when you have a fraction, which we'll talk more about fractions next class, we're going to do a lot more fractions next class. When you have fractions, you need to make sure, first of all, there's not a radical in the denominator. Look at the bottom of my fraction. Is there a square root there? No. So that's good. You also need to make sure that you can't simplify the fraction. What number's outside in the numerator? 3. What number's outside in the denominator? Can you simplify 3/5? No, and if you don't know, guys, remember we love the calculators.
Wait, what did you say?
Can you simplify 3/5?
No.
And again, if you don't know, we love the calculators. Type it in as a fraction, 3 over 5, and it stays 3 over 5. 3/5 does not simplify.
So you were talking about how
We're checking to make sure this is done.
Yeah.
Okay, it's an equivalent value, but just because it's an equivalent value doesn't mean that's the correct answer. Okay? So we have to make sure that we're following our rules. No square roots in the denominator, no square roots that are divisible by a perfect square other than 1, and nothing inside or outside the radicals can be simplified. We good? All of that's a little refresher, right? We've simplified radicals before. Do we need a little break for a minute or two? Yeah? Okay. We'll take a little break. We're going to take a minute break. 2-minute break. We'll take a 2 minutes. We are now going to go to our adding and subtracting. I know it's a little out of order. We're skipping our multiplying. We're not doing that today. We're going to do that next class. Go to adding and subtracting. See, at the bottom it says adding and subtracting. Okay?
Yeah, why are we skipping the multiplying?
Because today we're doing simplifying, adding, and subtracting. But whenever you do a foldable, it just has to fit the right way. So adding and subtracting is a longer list. Okay, so our rule when we are adding and subtracting is the number inside the radical must be the same. This is just like having like terms. Whenever you're adding and subtracting x's, you only could combine them if they both had an x or both had an x squared, right? Same thing with our radicals. You only can combine them if they both have a square root 2 or if they both have a square root 3. Now the tricky part is just because they don't match at the beginning doesn't mean that your radicals won't eventually match. You might have to simplify the radicals, and then once you do that, then the radicals will be the same. Okay? Now, they're going to start out pretty easy, guys. Looking here. Do my radicals match? Yeah, keep the radical so it stays square root 5, Gavin. So we're on the adding and subtracting days, guys. Looks like this. Are we all in the right spot? You just open it all the way up. So we were here like this, right? And then see how at the bottom it says adding and subtracting, just flip it all the way up. Now we're here, like this. You good? Okay, so when you add and subtract, keep your radical. Do you need help? I know, we haven't done foldables before. Again, flip it up. We're going to do this one. Okay, keep your radical, and what do you think we're going to do with the coefficients? Add them. 3 plus 4 is 7. Again, we have to follow our same simplifying rules. Is 5 divisible by a perfect square? No. So we're done. What do you think we should do? Check on the calculator. Very good. 3 square root 5. Now, when I do plus 4, you have to arrow to the side to get out of the radical, Gavin. So we're all typing this in our calculator with me. So 3 square root 5 plus 4 square root 5. Again, when you're under the radical, right, Ava, you have to arrow over to do the plus. Did we type this in the calculator with me? Hit enter and then type your answer in, 7 square root 5. And they should both be the same decimal. Again, this whole unit is over equivalent values. Okay, whatever your original is, whatever your answer is, should match exactly. Good? Next one. Now I have 3 terms. Because this is a coefficient, that's your radical, it's glued together, that's one term. Remember, terms are separated by addition and subtraction signs. There's no addition or subtraction sign between the 3 and the square root of 7, so this is all one term. This is all one term. This is all one term. Do all of my radicals match? Yeah. Square root 7, square root 7, square root 7. So I keep it square root 7. When you add and subtract, the radicals must be the same and they do not change. Then I'm going to add or subtract the coefficients depending on what's in front of them. So 3 minus 2 is what? 1 plus 9. 10. So 10 square root 7. Is 7 divisible by a perfect square? No, 7's prime. So let's check ourselves. 3 square root 7 minus 2 square root 7 plus 9 square root 7. And then 10 square root 7. And our answers are the same. Okay. Are we thinking so far these are relatively easy? If the radicals match, keep the radical, add the coefficients. Okay? Next one. I have two terms here. I have a square root of 5 and then a 3 square root 5. Do my square roots match? Yes, keep it square root 5. What's this square root 5's coefficient? 1. Even though there's not a coefficient there, it has a coefficient of 1. Just like if you had an x, x has an understood coefficient of 1. So 1 plus 3 is? 4. Type it in your calculator to check. Square root 5 plus 3 square root 5. And we get 4 square root 5. And my decimals match. Good? Now I will tell you guys, they're not all going to be this easy where the radicals are already fully simplified and where the radicals match. We might have to first simplify our radicals, okay? Or sometimes the radicals won't all match. Looking at number 4, how many terms do I have on number 4? 4. I have a 2 root 7, a negative 3 root 10, a 12, and a negative 5 root 7. Okay, so I have 4 terms. 1, 2, 3, 4 terms. Okay. 7's what kind of number? Prime. Can't simplify. 10. Is 10 divisible by any perfect square? No. Can't simplify. Does 12 even have a radical?
No.
Can't simplify. And 7's what kind of number? Prime. Can't simplify. So can any of these radicals be simplified? No. Okay, so we're ready to combine like terms.
But the radicals are the same.
Not all the radicals are the same. That's okay. We're looking for ones that are the same. So if I have a square root 7 here, is there another square root 7? Right here. Okay? So keep your square root 7. And what am I going to do with the coefficients? 2 minus 5 is negative 3. Okay? So we combine these two terms, cross them out. Okay, cover them up. Are those two that are left over like terms? No, so can I combine them? No, so I'm just dropping them down. Not everything's going to be able to be simplified or combined. Again, you cannot add or subtract terms unless they have the same radicals. You cannot add or subtract terms unless they have the same radicals. It is okay to have terms that cannot combine, just like how we were doing quadratics and we had like 3x squared plus x minus 4. None of those were like terms, we just ended up having 3 terms in our answer. That's acceptable. Okay? We good? What should we do?
Can you show the top row of problems as well?
What should we do? Check. This one is going to take a little bit of time, but guys, you will always know if you got the right answer. So please make sure you take your time to check all of these. And then type in your answer. Biggest mistake when we're typing in our square roots, guys, make sure you arrow over whenever you're done with the square root sign. And we get equivalent decimals. Good? Are we seeing how this is super similar to our rules with our variables? Your rule with combining variables is the variables must have the same variable, same exponent. You keep the variable in the exponent, you add or subtract the coefficient. Same thing with your radicals. The radicals must be the same. You keep the radicals, add or subtract the coefficients. Same exact rule. Okay, we good?
Wait, what did you say?
Same rules for variables as with our radicals. Same exact rules. Okay, next one. How many terms do I have on number 5?
5.
5. I have a square root of 11, square root 13, square root 11, 17, square root 13. Okay. What kind of number is 11? Somebody said it. Prime. 13? Prime. 11? Prime. 17 doesn't even have a radical. 13 is prime. So can any of these radicals simplify? No. So we don't have to simplify any of the radicals. Now we're going to look for like radicals. I have a square root 11. Is there another square root 11? Yes. So keep it square root 11. If this square root of 11, Gavin, doesn't have a coefficient, what do I put there? A 1. So that's a negative 1 minus 2. What's negative 1 minus 2?
Negative 3.
Negative 3. Then I have a square root 13. Is there another square root 13? Yes. Square root 13. What am I going to do with my coefficients? Add them. Positive 2. This one doesn't have a coefficient, so I'm going to put a 1. So what's positive 2 plus 1? Positive 3. There you go. And then last but not least, your plus 17. Now guys, when we're writing out terms, does it matter what order you write your terms in? Nope, it does not. Okay. Are any of these like terms? Nope. We good? Okay, we're going to like this next one a lot. Okay. Square root 10 plus square root 2. 10. Is 10 prime?
No.
No, but is 10 divisible by any perfect square?
No.
No. So square root of 10 cannot be simplified. 2 is what kind of prime? So I can't simplify the square root of 2. Are my radicals the same? No. Can't do anything. That's my answer. Is it okay to not be able to combine like terms? Or, sorry, if they're like terms, you would always combine them. Is it okay to not have like terms and not be able to combine terms? Yes. Okay, not all terms are going to be like terms. Not always will you be able to simplify and combine your like terms. Good? So I will tell you guys, those first 6 were pretty easy because we didn't have to do any simplifying of the radicals. These bottom 4 are going to take us a little bit longer because we're going to have to simplify radicals. So I'd make sure we're sitting up. We have 4 more problems, guys. We have 4 more problems and then we're done with notes for today. So eyes are open and we're paying attention, okay?
Do you have any homework, Will? Do you have any home besides? Well, is this the guy homework?
We're going to get a homework sheet.
Oh.
This is notes. Square root of 3. 3 is what kind of number? Prime. Can't simplify that. Square root of 48. Is 48 prime? Is 48 on my list? No. So let's go to our calculator, all of us. Go to y equals 48 divided by x. Go to your calculator, 48 divided by x. And we're going to go to our table. 48's not on my list. 2 and 24 aren't on my list. 3 and 16. Oh, 16's on my list. So I'm going to drop down my 5 square root 3. Because we said 3's prime. So you cannot simplify the square root of 3. And then how am I going to rewrite my 48? Very good. So plus square root 16, square root 3. Remember, we always put the perfect square before the non-perfect square when we separate our radicals, right, Noah? Set up for me. So 5 square root 3 can't simplify. What is the square root of 16? 4. Square root 3. So guys, at the beginning, did my radicals match? No, you might have thought, oh, we can't combine them. But once you simplify the square root of 48, what happened? My radicals now match, so now I can add them. Square root 3, leave it square root 3. What do I do with the coefficients? Add them. 5 plus 4 is 9. Go to your calculator and we're going to type in my whole original. 5 square root 3 plus square root 48. Everyone's typing this in. Ava. And then 9 square root 3. And my decimals match, so we are correct. Good? Also, when you get your answer, make sure the number under the radical is what kind of number? Well, it won't always be prime, but it won't be divisible by a perfect square. Okay? Okay, next one. Do my square roots match? No, 6 and 54 are not the same. Square root of 6. Can square root of 6 be simplified?
No.
Is it divisible by any number on my perfect square list?
No.
No. So I'm going to drop down to square root 6. 54. Is 54 on my list? No, but it's a pretty big even number, so let's go to our calculator and we're going to do 54 divided by x. Everyone's doing this with me. 54 divided by x in our y equals. And you are wanting to look for perfect squares it's divisible by. 54 is not on my list. 2 and 27 aren't on my list. 3 and 18 aren't on my list. Then I have a decimal and a decimal. Definitely always skip the decimals. 9 and 6. Are either of those on my list?
Yeah.
Yes, 9 is. So I'm going to do minus 5. Square root what?
9.
9 square root. Always put the perfect square before the non-perfect square. Drop down your 2 square root 6 minus 5. What's the square root of 9 become? 3. So times 3 square root 6. Keep your 2 square root 6. And what does this negative 5 times 3 become?
Negative 15.
Negative 15. Great job. Square root 6. Now do my square roots match? Yeah. Square root 6, square root 6, keep it square root 6. And what am I going to do with my coefficients? 2 minus 15 is negative 13. What should we do now? Check on your calculator. 2 square root 6 minus 5 square root 54. And then negative 13 square root 6. Good? Okay, number 9. Do any of these 3 currently match? Does that mean that's my answer? No, because you might be able to simplify them and then make them match. Okay, is 12 divisible by a perfect square?
4.
4 and
3.
3. So this is going to become square root 4, square root 3. Can you simplify the square root of 3? Nope. So plus 6 square root 3. Can you simplify the square root of 6? No, because it's not divisible by any number on the board. That's our perfect squares. Guys, open your eyes. We have 2 problems left. Let's go. What's the square root of 4? 2. Root 3. And we already said the other ones don't simplify, so I'm just dropping them down. Okay, I have 3 terms here. Do any of my terms have the same radicals? Are any of them like terms? Yes, I have square root 3, keep it, square root 3. Then I have 2 plus 6 is 8. Drop down here, plus square root 6. What should we do? Check on your calculator. Square root 12 plus 6, square root 3 plus square root 6. So 2 things to remember the most when we're doing adding and subtracting, guys. The radicals must match in order to add them. Combine the coefficients, don't change the radical. Okay? The second part is just because they don't match at the beginning doesn't mean that you can't simplify the radicals and then they will be like radicals. Good? Last one. Do my radicals match? Nope. Can you simplify the square root of 2? Do you think you can simplify the square root of 128? Probably. So I'm going to drop down my 3 square root 2. And then I'm going to go to y equals and do 128 divided by x. Go to the table. 128 is not on my list. 2 and 64. 64 is on my list, so I'm going to do minus the square root of 64, square root of 2. Again, always put the perfect square first, so that's why I put the 64 before the 2. 64 is on my list, 2 is not. So 3 square root 2 minus, what's the square root of 64? 8 square root 2. Now do my radicals match? Yes, square root 2, square root 2, square root 2. 3 minus 8 is negative 5. Type it in your calculator to check. 3 square root 2 minus square root 128, and then negative 5 square root 2. Do they match? Yes. Okay, we good? So we are done with our notes for today.